All right, welcome back, everyone. We have 8.1, solving right triangles. So your learning goal is to use trig functions to solve right triangles. We can use trig functions for non-right triangles, but only in very, very certain circumstances using law of sines and law of cosines. So for now, I want you to think of this as that we're only using trig functions for right triangles, and when we don't have right triangles, we cannot use them in the way that we're using them today. Now let's go over some, refreshing material on triangle nomenclature. Okay, so there are three sides to a triangle, very clearly, and each one has a name when we're using trig functions. So we have the hypotenuse, the opposite, and the adjacent. The hypotenuse is always opposite of the right angle. So here is your hypotenuse. That one doesn't move. The thing about the opposite and the adjacent, which are the side across from the reference angle and the side next to the reference angle, is it changes based off which angle you're referencing. So if I'm referencing this one, okay, the opposite angle is here, right? And the adjacent angle is right next to it. You can kind of see, very clearly which one's opposite and which one's adjacent, okay? But if I change it and I make this my reference angle with theta, then all of a sudden this one becomes my opposite and this one becomes my adjacent. Okay, so those two are going to move depending on which one you're trying to talk about. Okay, but hypotenuse always is the opposite of the right angle, and that does not change. Okay, now we have 6 trig functions that we will be working with today, and we're really going to just be focusing on let's just talk about each one here, okay? Let's call this, let's go, this is ABC, right? Here is our angle here, okay? So this is our hypotenuse, okay? For using these trig functions, right, depending on the reference angle you're trying to look for, we have a system of which side we use, okay? So for sine, we use the opposite over the hypotenuse, which I'm going to abbreviate, okay? So if this was my theta for sine, it would be opposite over the hypotenuse, okay? That's where you get, if you remember SOHCAHTOA, that's where you get the SO, okay? Then you have CA-TOA, all right? So cosine is your adjacent over your hypotenuse, and then tangent is your opposite over adjacent. Okay, so look, you can see it right there. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay, now the color scheme here is done for a reason. Sine and cosecant are linked. Okay, cosine and secant are linked. Tangent and cotangent are linked. These are the reciprocals. Okay, and what that means is cosecant is the same thing as 1 over sine. Secant is the same thing as 1 over cosine. Cotangent is the same thing as 1 over tangent. Okay, now what does that mean for, which side you're using? Okay, that means that cosecant uses the opposite of what sine is, so it's hypotenuse over opposite. Secant is the opposite of cosine. It is hypotenuse over adjacent. And cotangent is the opposite of tangent. It's going to be opposite over adjacent. Okay, so these reciprocals are just the flipped of these. So if you forget, oh man, which ones are these? Just think back to what these are and flip them. Okay, now the last thing is, big point of confusion that I see is with sine and cosecant. Because it has a C for cosecant, we think that it is a reciprocal of cosine. But for whatever reason, cosine and secant, those are reciprocals, okay? And that'll probably confuse us a little bit. I personally think that these should have been flipped, but, they're not. So be careful, okay? All right, in this one, we're just going to find the following trigonometric values. But we're just going to be doing opposite over this or adjacent over that. We're just going to be setting them up, okay? So tangent of A, that means this is our reference angle, so right here. Well, tangent is opposite over adjacent, so opposite over adjacent. So 4 over 2, which would just be 2. But I'm not so much concerned about simplifying right now. Secant. Remember, secant is a reciprocal of cosine. Cosine's adjacent over hypotenuse. So this is hypotenuse over adjacent, okay? But our reference angle is B this time. So my hypotenuse is still here, but my adjacent is 4. So it's 2 times square root of 5 over 4, which that can be simplified. Not too concerned about that. Cosecant of B, right? Remember, cosecant is the reciprocal of sine, so that's hypotenuse over opposite. We have B as our reference angle, so hypotenuse is still here. Opposite is 2, so that's 2 times the square root of 5 over 2. Cosine, adjacent over hypotenuse, okay? Our reference angle is A, so adjacent is 2, hypotenuse still hasn't moved, so 2 over 2 times the square root of 5, which again, that can be simplified, but I think you guys can simplify that, okay? Then we have our sine of A. Here's our reference angle. Sine of A is opposite over hypotenuse, okay? So opposite, 4 over hypotenuse, 2 times square root of 5. So that is 4 over 2 times square root of 5, which again can also be reduced, okay? So here we were just setting these up so that we can use our trig functions to find missing sides or to find missing angles, okay? All right. Now let's find the measure of these designated sides. So this is what we do. So I'm going to do this one. You guys will do this one, okay? Now notice how I'm not saying use sine or use cosine or use cosecant or use secant or cotangent or any of those things. You have to let the triangle dictate those things. So these are both right triangles. And based off of the information you're given, will dictate which one of those you use, okay? So I see my reference angle is here, and I'm looking for this side, x, and I have this side 13. I don't have the hypotenuse at all. So that'll eliminate sine and cosine off the bat because they both need the hypotenuse. So look, tangent is perfect. Opposite over adjacent. Perfect. So we get sine of 32 degrees is equal to x over 13. Okay? Now from here, it's just like solving for x. Multiply 13 to both sides. X is equal to the sine of 32 degrees times 13, or 13 times the sine of 32 degrees. Either one is fine, okay? Now to do this, we're gonna need our calculator. So let me bring that up, okay? And sorry, I have a bunch of stuff already in there. There we go. Okay. Nope, it's still there, whatever. Okay. So what we're gonna have to do is, if you look right here, you can see this little trig button right here. That's for this calculator where we get these options, okay? But if you're using a scientific calculator, you should see the actual buttons there, okay? So I need sine of 32 degrees, and then I'm going to multiply that by 13, and I get 6.88895. Did I do that? Yeah, 32 times 13. Okay. So we get 6.88895. So x is equal to 6.88895. Okay. Oh my goodness. Well, that's what's wrong. Literally, wow. I was like, we need tangent, but I put a sign in here. Okay. Let's redo this. This is tangent, okay? Now I could have restarted this and you would have never seen it, but sometimes I think it's important to leave those errors in there so that we can see that these just things, they kind of happen, right? All right, more reason why you got to check your work, okay? So that should have been tangent. So I'm going to do this again. Oopsie oops. So that's tangent of 13. Where's my multiplication? Times, oh my goodness, I'm about to make another mistake. Tangent of 32 times 13. Okay. That looks much better. Okay. X is equal to 8.1233. I'm going to round to the hundreds. So X is approximately 8.12. Okay. So you just found the side of this with only an angle and only one side. All right. Not even having this. Well, technically two, because this is 90 degrees. Okay. But that's pretty cool. All right. All right. Let's have you guys do the next one. Okay. I'm just going to shift my calculator over here. Let's have you guys do that. It's very, very similar type of problem here. But I want you guys to pause it and give it a try. All right, so hopefully you got it. Okay, you could see we're looking for this side x. We're given this angle. We have this. Okay, so we need to kind of look. What's the relationship? Well, this is opposite. And I have hypotenuse. So this time I will correctly use sine. Okay, so sine of 57 degrees is equal to the opposite over the hypotenuse, which is x. Okay. Now, when you get in these situations, the x on the bottom, that's okay. Times x to both sides, it cancels. And then you would divide sine to both sides. And you get x is equal to 10.8 divided by sine of 57 degrees. Okay? So let's put this into the calculator here. So we have 10.8 divide. Click on the calculator. So we have 10. Really, calculator? Let's try this again. 10.8 divided by the sine of 57 degrees. So let's click our trig button here. The sine of 57 degrees. Okay? And we get 12 point, so x is equal to 12.8775, which is general rule. I'm going to round to the hundreds. And we're going to get x is equal to 12.88 approximately. Okay? So, hopefully you got that one right. This is missing sides. We're going to do missing angles in a second here, but it's really all about just finding the trig function that you need given the information you have for that triangle. Okay. All right, let's get rid of this calculator here. Okay. So find the measure of the designated angle. All right, it's a little bit different this time. We have sides, but not angles. Now these are right triangles. Here's a right angle. And here is a right angle. Okay. Be careful assuming right angles if you don't see that. Okay, because sometimes the drawing could just look like it, but maybe it's an 89, right? Okay, so we have a reference angle here of x that we're looking for, and let's check its relationship. This is the opposite of it, and this is adjacent. Okay, and here is your hypotenuse. So we don't have the hypotenuse, so instantly we can roll out using the hypotenuse. So opposite over adjacent screams tangent. Okay, so tangent of x is equal to 4 over 13. Okay, now x is not the same as 4 over 13 because we are taking the tangent of x. Okay, what this means is that you need to use the inverse. So we're going to go inverse tangent to both sides, kind of like we did, with the logs, right? This cancels that, and we're left with x is equal to the inverse tangent of 4 over 13. Okay, so now let me get my calculator up here. When we use our calculator, if you notice when I click the trig button here, we have all the inverses listed right at the bottom. Now, in a scientific calculator, generally, if you see the buttons over here somewhere, the little blue markings would show for the inverse. Okay. Oh, well, baby crying. Okay. So, tangent of 4 divided by 13. Oh, I didn't plug that in right. Okay. Hold on one second. I'll be right back. All right. And we are back. And there's my pen. Okay. All right. So I entered it in wrong in the calculator. Shocking, right? So we do the inverse tangent of 4 divided by 13. There we go. And we get 17.1027. So x is equal to 17.1027, or x is approximately 17.10. Okay? So remember, opposite over adjacent. Okay, that helped us use tangent. We use the inverse to get rid of it, and then we have to plug in the inverse into our calculator. Okay? All right, so let's move that calculator over here. Here is one for you guys to try. Pause it and give it a try. Okay, so hopefully you guys got this, right? We see here this theta is our reference angle, okay? And so we don't have an opposite, but we do have a hypotenuse, and we do have an adjacent to that. So adjacent over hypotenuse, so we're using cosine. So cosine of theta is equal to the adjacent 4 over 5. Now we need to take the inverse cosine of each side. It cancels. And I'm left with theta is equal to the inverse cosine of 4 over 5. Okay. So we go to our calculator. We plug that in. So we have the inverse cosine of, 0.8. Really, that's the same thing as 4 over 5. Plug that in and we get theta is equal to 36.8699, or just approximately 36.87 as your answer. Okay. Now this symbol theta, you're going to see this a lot in trig, and that's how we call it. We call it theta. It is really no different than just a variable. Okay. Now, let's just talk a little bit real quickly about what you could use this for. Okay. And there are a ton of answers for this. Oh, I should get rid of my calculator. Let's get that off the screen. There are a ton of answers for this, all right? But I want to focus on a little bit of application. Obviously, you're going to use this a ton in pre-calculus and calculus, but think about just a classical problem. If this is a mountain, okay, this is a mountain right here, and you're here, and this is, along here, okay? And this is a long time ago, all right? Or, actually, let's say it's today with all the advanced technology that we have in the world, okay? And you're sitting here and you go, I want to climb this mountain, but I don't know how tall it is, okay? Well, you can't really just take a measuring stick, right, or a tape measure, and, you don't have a GPS either, okay? And so how would you figure out this problem, right? Well, if we set up a triangle here and here, back to you, okay, well, we know that this is 90 degrees, okay, and if you can measure this distance, well, then you figure out this angle and you get this height. Now, that was a lot of if you figure out this and if you figure out that, right? But figuring out your distance horizontally is a little bit easier. Figuring out your angle here actually isn't too difficult, right? You can even use a simple compass with a telescope, okay? But what's the real point of this example? You're probably not going to do it this way, but this helps us solve problems with triangles, problems that we don't think triangles apply to. My first guess, if I would have just given you a mountain and put you here, like I did, and said, find the height, you would have not thought about a triangle. But we can use these right triangles to place them certain places on top of other things and use those trigonomic functions to figure out answers. So when you move from this point and you get to pre-calculus and calculus, you will do this. You will sit here and go, I have a problem that has nothing to do with the triangle, but I'm going to throw a triangle in there to figure it out. Okay? So that's all I got for you guys today. I hope you guys enjoyed it, and I will see you next time.